Hi everybody. So in this video we're going to look at solving problems with sets and set notation. So in our first question we're told that the Venn diagram shows a universal set epsilon, which is this universal set here, and it contains all the elements and the sets x, y and z, which are each of these. And the elements are 6, 3, 7, 5, 2, 9, 4 and 8. And as we work through questions A, B and C, we're going to discuss what each of these symbols mean. Then for part A, the number of elements is n, where x is in union with y, and for this union we can think of an OR, so x or y, and then this dash symbol means the complement, so we're looking at the opposite of this. We can think of this as not, so not x or y. So if we begin with x in union with y, and we identify each of these, this would be an element that is either in x or it's in y. But because we're looking at the complement of this region, this means that it cannot be x or y. So the elements that fit this criteria are the 8 and the 4. So I'll just erase the other elements. And you can see that the number of elements that fit this are 2, the 8 and the 4. So for part B, find the number of elements where we have a complement of x in union with z intersecting with, and we can think of intersecting as an and. So not x or z, and it must be y. So we'll begin with x in union with z, which are these elements. We'll find the complement of this, which are the other 2 elements. And then it must be intersecting, so and y. And the only one that matches this criteria is this 7. So you can see that the number of elements within this region is equal to 1, and that's just for 7 here. Okay, so for part C, on the Venn diagram, shade the region that represents the set x in union with y intersecting with z. So we'll begin with x in union with y, which are each of these. But then this must be intersecting with z, which means we're only looking at the elements that are inside the z set. So we can discount the 6, the 3 and the 7. So the region is this one shaded in green. Okay, let's try another example. So in our second example, we're told that epsilon contains the numbers from 1 to 13, and this is our universal set. And this has 3 subsets, x with these elements, y with these, and z with these elements. And then we've been asked to work through questions A to D. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the work solution. Okay, so welcome back if you had a go. So the best way to do this is to identify the elements which have been arranged within the set. So we've got the 1, 2, 3, 4, 5, and 7, 8, 9, 10, 12 and 13. So we need to find where 6 and 11 go. But we can see here that 6 is within the set of y, but it's also within z. So that would be this region, because it is not within x. And then the 11 is within the set of x, but not within y or z. So the 11 must go here. Then for part B, list the members of the set not y intersecting with z. So we'll look at not y, which are each of these in blue. But there must also be not y and z. So it must be within this circle, which means we can eliminate the 11, the 1, the 4 and the 10. So the members of this are 2, 5, 7 and 8. And then for part C, List the members of a set which have a complement of x in union with z intersecting with y. So we'll begin with x in union with z, which are each of these elements. But we want the complement of this, so this will be the 9, the 12, the 4, the 1 and the 10. So I'll eliminate these greens, and then it must be intersecting with y, and only the 9 and the 12 fit within this set. So we'll eliminate each of these. So the members of this region are 9 and 12. And then for part C, find the number of elements that are not x intersecting with not y. So we'll begin with not x, which are each of these, and not y, which means we'll eliminate the ones which are, and you can see we have 6 elements left. So we'll have a number of elements of 6. Okay. Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, please like and subscribe, and you can download the full lesson and worksheet from my website, mrmathematics.com. I'll leave a link in the description below.